All right, 51, we're going to write a polynomial that is fourth degree, has these three zeros, and includes the point -110. They use the language solution point. Basically, it just means that that point is on the graph. Now, fourth degree polynomial is sort of a reminder that if you have a complex solution, its conjugate is automatically another solution. That's the complex conjugates theorem. The idea being, the only way you're ever going to get a complex solution is by doing quadratic formula using the polynomial. And in the part where you take the square root to get the complex solution, there's going to be a plus or minus version there. So that's why you're always going to get a positive and negative version of the complex number. The conjugate, the complex and its conjugate will always come together. So that being said, let's jump in, make sure we get a fourth degree polynomial. We will hold off on the solution point for now. Don't worry about that quite yet. Let's just get a polynomial that has these 3 or 4 zeros. So if x is 1, the factor version is x minus 1. X equals 2 is a solution, then x plus 2 is a factor. And then x plus 2i, x minus 2i are two other factors. And since I have 4, I'm going to do 2 of these at a time. And you always want to do the conjugates together. It's way easier that way because most, all of your I parts will go away. The complex number will become purely real when you FOIL these together. So I'm going to start there. That'll be x squared minus 2xi plus 2xi, and then minus 4i squared. And at the same time, we'll go ahead and do these two. So x squared plus 2x minus x minus 2. And I'll simplify on the next step. So x squared plus x minus 2. This will be x squared. These will add to 0. And I squared is really -1, so -4 times -1 is plus 4. And then we'll multiply those out. So x squared times x squared is x to the 4th. X squared times 4 is 4x squared. X times x squared is x cubed. X times 4 is 4x. Didn't do a very good job lining these up. -2 times x squared, -2x squared, and minus 8 at the end. Yeah, probably could have done a better job of keeping that organized. So x to the 4th, we have x cubed. 4x squared minus 2x squared is 2x squared plus 4x, and then finally minus 8. So this is our function. This is our polynomial. This will have the 4 zeros shown or given to us in the beginning. Now if you graph that, you're only going to see 2 of those because only 2 are real. The other 2 are complex. So if you watch that video, they exist in another parallel dimension. So you won't see them, but mathematically they should be there. But that should be your function. And you want to be able to do this completely by hand. If you want to graph it for now to kind of see how things are going, that's fine. What we really want to know right now is, well, what is f of 1? Or -1, sorry. So let's figure out, what is f of -1? And just remember that you want to stretch the graph. You want to do some kind of vertical change. You want to shrink it down, squish it, shrink it, stretch it, whatever, however you want to think about it. But you don't want to shift the whole graph up or down. That'll change your zeros. Zeros have to stay the same. So what you can do is multiply the entire polynomial by something that stretches it or squashes it down, but that you can't lift it. You can't add something at the end to shift the graph up. That will change your zeros. So let's plug in -1 and see what happens. -1 to the 4th plus -1 cubed plus 2 times -1 squared plus 4 times -1 minus 8. So that's going to be 1 minus 1. That's going to be a positive 1, so plus 2 minus 4 minus 8. So f of 1, that goes away. That's minus 12 plus 2 is -10. So f of -1 as is right now is -10. So it's almost what you want. You want it to be +10 though. So just to kind of do a little sketch to practice this by hand. Is this something I will ask you to do on quizzes and tests? This polynomial, this polynomial was a positive leading coefficient with 4 zeros. So both ends are going to point up. It's 4th degree, so it's even, and it's a positive leading coefficient. The y-intercept's at -8. So I'm just going to put a few points on here that I know. 1 and -2 are some real zeros you have. So it's going to be something like this. And it may even look like a parabola. It's probably got a few more little things going on. But it looks something like that. And we just figured out that -1, -10 is actually on here. So maybe it's more kind of this shape, something like that. That maybe got a little bit worse. But that's basically what we're seeing. What we want to do is flip this thing around so that it's got a point at -110, and the zeros stay the same. So again, to do that, we can multiply the whole polynomial by something, but we don't want to just slide the whole graph up. As we slide this whole thing up, we might get that point to be at +10, but all the zeros are going to be somewhere. There actually won't be any more real zeros if you scoot the whole graph up. So really all it's left to do is just think about, what do you need to do to -10 to make it +10? And hopefully it doesn't take you too long to realize that you want to multiply that by -1. So here's sort of the simplified process the way I would go about it. As is, f of -1 is -10. That's kind of taking all this work out of the middle and just jumping straight to the answer. If you want that to be a +10, you'll need to multiply it by -1. And if you do it to one side, you got to do it to the other. So what we're going to need to do is take our polynomial and multiply it by -1. So if f of x was x to the 4th plus x cubed plus 2x squared plus 4x minus 8, and we know that we'd like to multiply that whole thing by -1, then we do it to both sides. And your function, I'll call it g of x, just to show that this is a little bit different function than we started with. You need it to be -x to the 4th minus x cubed minus 2x squared minus 4x plus 8. All right, and that would do it. If you plug in -1 for x, you should be able to see that that will give you 10 for a solution point. I think the directions can be a little confusing, so I'll kind of take it piece by piece. Really, they're just trying to get you to use the fundamental theorem of algebra to express this 4th degree polynomial as 4 separate factors. And those factors end up being in the complex system, so they kind of start with, all right, show these in the rational system first, then the real system, and then finally in the complex. So I'll kind of walk you through what they're getting at. Usually what I find is most students understand this problem better than they think. It's just the language is a little strange. So first thing we want to do, if we're going to break this thing into its factors, we need to factor it out. And I'm going to do a u substitution. You may not need to, but again, to kind of get you used to that idea. So when you do chain rule next year, this is the u substitution is not the challenge, it's the rule itself. So usually it's the middle variable. And let's just see if we did u squared and u here, would it check out if that was x squared? So it looks like that would be good, and x squared would be x to the 4th, so that would be good. So u squared minus 6u minus 7, you just replace the x squareds with u's, and now you've got a normal kind of trinomial with something squared, something that's not squared, and a constant at the end. Factors of -7 that will add up to -6 will be -7 and +1. Okay. Now, normally if we're solving, we could just jump right to the solving step. Now, we are supposed to factor here. So we're getting ready to do part A. I'm going to put the x squared back in. And what we've got here, this is something that, this is the end of step A. Factor this in terms of numbers over the rational system. Now, this is a difference of squares, but 7 is not a perfect square, so if you try to take the square root of it, it's going to be an irrational number. So if you're keeping this in totally rational numbers right now, there's nothing more you can do. The only way to factor this is to go to complex. The only way to factor this is to go to irrationals. So that's where you would stop for part A. Now we're going to continue going. It is a difference of squares again, so it can be broken down. Seems kind of strange, but it fits the rule. X plus the square root of 7 times x minus the square root of 7. I don't think I said it backwards when I wrote it. And then this can't be expressed over the irrational numbers any further, because this is the only way to keep it real. So this would be the end of step B. And then finally, to show this in its fully factored form, because fundamental theorem of algebra says if it's a 4th degree polynomial, it will break into 4 factors. So to break this into its full 4-factor form, you have to jump to the complex system. So that'll be our final part. So x minus the square root of 7 over x plus the square root of 7. And if you're a little unsure how that'll go, sometimes a good thing to do, I think, is to just take this off to the side and solve it. So x would be plus or minus the square root of -1, so x would equal plus or minus I. And then you could always turn that back into factors. So x minus I times x plus I. Again, it's weird to think of factoring that. So again, I think it's easier to solve sometimes and just turn those solutions back into factors. But that's your fully finished 4th degree, wow, it's a tongue twister. That's your final 4th degree polynomial expressed as factors. For 61, your goal is to find all the solutions to this polynomial. You are given one of them. There are 2 main approaches that I find kind of equally as involving. So I'm going to take you through both, and I'll let you decide which you think is easier. One way is to do synthetic division, because if we turn this into, or this is one solution, basically anytime you have one solution, you can divide that one solution out with synthetic division, because it is, as a factor, the x minus that solution. So 1st degree factor. The other way is to take the idea that this is a complex solution, know that there is a conjugate to it that's also a solution, and divide both of those out at the same time. Right? That's going to mean foiling those 2 things together and then doing long division. So those are the 2 methods. I'm going to do both, and again, you can decide what you find easier. I have found over the years that probably a slight majority like synthetic division better, but it's really pretty close. So it's completely up to you. So method 1, I'll do synthetic division. So 5 plus 2i will go in the box. And I'm going to slide that down because I'm going to need a little more room. Leave yourself plenty of room between these coefficients up here, because you're going to need it. And you're probably going to need some scratch paper either way you go here. So 1 comes down, 5 plus 2i is next, -7 plus 5 is -2, and now the fun begins. So on my scratch work off to the side, we'll do -10 plus 10i minus 4i, got a little stray mark there, and plus 4i squared, which is really minus 4. All right, so -14 plus 6i is going to go next. So add those, you get -15 plus 6i. And now for some more foiling. 5 times -15 is -75. 5 times 6i is 30i. Positive 2 times -15 is -30i. And 2i times 6i would be positive 12i squared, which is really -12. So -87, and then these add to 0. And that's really good because that means we have no remainder left. Now, once you've done synthetic division for the first factor, because 5 plus 2i was a solution, we know that 5 minus 2i is another solution. And you can continue on with the coefficients you ended up here. So 1 minus 2 plus 2i minus 15 plus 6i. And then we'll take that down. So 1 times 5 minus 2i. All right, the 2i's are going to be gone, so that's just 3. That's convenient. And then 3 times 5 is 15. 3 times negative 2i is negative 6i. And those add to 0. So that leaves us with x plus 3 as our final factor. Method 2 is going to be doing long division. So in the beginning, there's a little bit of preliminary work. And then it's honestly, I think it's a lot easier after this first step. I don't know that I could honestly say this is an easier way than the other one. Both of them are going to involve some foiling of complex numbers. So it's really, it's a kind of a trade. I don't know. It's kind of a coin flip, I guess. So whatever you're more comfortable with. But what is true is that 5 plus 2i and 5 minus 2i are solutions. So since 5 plus 2i and 5 minus 2i are solutions, we know that x minus each one of those is a factor. So x minus this whole term would mean both of those become negative. X minus 5 minus 2i. And x minus this term means x minus 5 but plus 2i at that time. So let's multiply this out and see what we get. You get x squared minus 5x plus 2xi minus 5x plus 25 minus 10i and then negative 2ix or xi plus 10i. A lot of things that they're going to add out now. And then negative 2 times 2 is negative 4, but times I squared makes it positive 4. So let's see what we get when we put all that together. We've got an x squared. We've got a minus 10x. These add to 0. These make 29. And these add to 0. So that means that in a factor remainder theorem form, if your polynomial can be written as this times one other factor, and that creates your original polynomial. So we can divide the polynomial by these two factors combined, and that's going to give us our third factor. So the long division part of this is actually, in my opinion, pretty easy, pretty straightforward. If we are going to divide x squared minus 10x plus 29 out of the original polynomial, which is x cubed minus 7x squared minus x plus 87. Let's see what happens. So to get x cubed from x squared, multiply by an x. So that's going to give you x cubed. When I subtract, I like to change all signs just to make it easier to keep straight. That adds to nothing. That becomes 3x squared. That's going to be negative 30x, and 87 will come down. So now multiply x squared by 3 to get 3x squared. So 3 times x squared minus 30x plus 87. These are exactly the same, so when I subtract, they'll be gone. And x plus 3 is your final factor.